Okay, now I will show you how to solve example 40. So given that a function f is defined as follows. So you are given fx equals kx squared plus 2. Okay, where x less than 1, for x minus 1, where x greater than or equal 1 less than 3, and 7 when x greater than or equals 3. So the question is determine the value of k where the function is continuous at x equals 1 and b is fx continuous at x equals 3. Okay, now you are given three expressions in one function where we have expression 1, expression 2 and expression 3. Okay, now to solve this question, what we need to do is from this equation, okay, from this function, we divide into two number lines. Okay, the first number line is at point 1. As you can see, this one is x less than 1 and this one is x greater than 1. So we can draw the number line here. So this is 1. Okay, this is 1. As you can see, this is 1, the point to be approached, and we have x less than 1 and we have x greater than or equals -4, x greater than or equals 1. So for x less than 1, the function is kx squared plus 2, and for x greater than or equals 1, we can see here the function is 4x minus 1. So then we can get the limit from the left and from the right based on this number line. And for the second number line is at point 3. As you can see, this is point 3, where for x less than 3, so we are going to approach 3. Okay, for x less than 3, okay, the function here is 4x minus 1. For x greater than or equals 3, so then we refer to this part, which is 7. So then we can find what is the limit of x as x approaches 3 from the left, and the limit of fx as x approaches 3 from the right. Now now as you can see, in this number line, we have 2 points to be approached at point 1 and at point 3. So now to answer question A, determine the value of k where the function is continuous at x equals 1. Now for question A, we need to check where is the location of expression contains k, and then as you can see, k is in k here. The unknowns k here is in the interval x less than 1 and then at point 1. So we need to approach this expression at point 1. So as you can see, the question mentioned here is the function is continuous at x equals 1. So from this question, we know that the left hand limit equals right hand limit, and since the function is continuous, then f of 1 is defined. So in this case, how to get the value of k? We compare the left and the right hand limit at point 1. So based on this timeline, at point 1, we have x approaches 1 from the left is kx squared plus 2, and x approaches 1 from the right is 4x minus 1. Then we write in the form of limit. Okay, so we will have limit of kx squared plus 2 as x approaches 1 from the left equals limit of 4x minus 1 as x approaches 1 from the right. And for f of 1, the value of fx when x equals 1, okay, we can assume this is already defined. Okay, now from this part, okay, solve the equation. So we have k using the direct substitution, substitute x equals 1 directly into these two functions. Then we have k times 1 squared plus 2 equals 4 times 1 minus 1, and then we will have k here is 1. So A is okay. Now to solve question B, is fx continuous at x equals 3? So now we are going to approach point 3. So we use the second number line at point 3. So in this case, to solve this question, okay, so we need to apply this number line. So as we can see, we need the condition of continuity is number 1, to check the limit of fx as x approaches 3 only exists or not. So now let's start with the left hand limit. So based on this number line, so we have the left hand limit of fx. So as you can see, this is the left hand limit. So for x minus 1, as x approaches 3 from the left, so then get the value. So we substitute x equals 3 directly into this one. Then we will have 4 times 3 minus 1. So the answer is 11. So for the right hand limit, we apply the same concept. Check the function. So the right hand limit is on the right of 3. So we have the function is 7 as x approaches 3 from the right. So based on the property number 1, limit of a scalar is a scalar. Okay, so then we have 7. So what we can say, since condition number 1 is not met, okay, so then we can conclude that left hand limit is not equal right hand limit. Therefore function fx, okay, therefore limit of fx as x approaches 3 only does not exist, where condition number 1 is not met. So in this case, the conclusion here is function fx is not continuous at x equals 3. And in this case, we do not need to check condition number 2 because of condition number 1 is already does not meet the condition in number 1. So we just write the conclusion after this calculation. That's all.